Okay, let's go ahead and get started. Thank you so much for joining us today. Our topic for today's presentation is operationalizing Java OR-Tools models with NextMove. So I'll be your host for today. I'm Renuka, and I'm joined by Lars Beckman, our head of decision science here at NextMove. On the right, we have an agenda for today. We will do a quick orientation to NextMove and the concept of decision ops. Then we will dive right into the demo from Lars of how to actually operationalize your OR-Tools model in Java. And then, of course, at the end, we will save some time for Q&A. So please feel free to use the Q&A feature that's baked into Zoom. The chat on the side, just make sure you toggle between, I think it says host and panelists and everyone. So make sure you toggle there. And we have some next movers on the call. So throughout the talk, feel free to drop your questions in and we can hopefully answer those live. And if we don't get to them, we will email you at the end. So not to worry. So with that, let's dive right in. So as I mentioned, NextMove is a decision ops platform, and our platform really accelerates optimization teams. So as you're iterating during development, NextMove can really help you confidently deploy decision models to production and do that in a repeatable way. So in the platform here in the center, we have the bottom, we have our infrastructure layer. So you can see we have infrastructure for hosting models, a testing suite with experiments like acceptance tests. And then one layer up, you can see the languages that we support. So that includes multiple languages, including Python, Go, and Java. The next layer up, you can see our optimization layer. So this really shows our integrations with popular modeling tools and solvers. So obviously today our topic is OR tools, but we also integrate with Eyes, Ample, Pyomo, and Gurobi. And then above that, we have our pre-built applications. So these are for very common use cases like routing and scheduling. And what's nice about these is they're kind of a jumping off point to get started, but they're completely customizable for your use case. So you can go ahead and get started using our templates and then jump right in and start customizing. And then on the top here, you can see how to work with the platform. So we have the NextMove CLI, our SDK, and of course our console. And Lars will be showing all of that today in his demo. So we've covered the middle of the platform here. On the left, you can see our inputs. So we work with inputs like your platform data, your operational data, business rules, and predictions as an input. And then on the right, we output your plan data. And that goes to things like ops tooling and customer apps. So let's talk about where NextMove sits in your system. On the right here, you can see we have a NextMove app. And we think about a NextMove app as a container for all of the assets used to solve a specific problem. So this app is going to execute your model. It will hold your model runs. It'll hold your versions and instances that you've created, as well as any experiment results. So for any tests that you run with your model as well. And you interact with this NextMove app from your decision service using unique API endpoints, so those bidirectional arrows there. And this service could be a routing service, scheduling service, and so on. And it can also be thought of as a plan client. So what it's going to be doing is reading from your database, submitting runs to your NextMove app, getting those results, and sending those plans on to your ops system for your operator to consume. So we mentioned decision ops as a concept, and NextMove is a decision ops platform. And how we think about decision ops is being an automated process that has checkpoints along the way for manually auditing. So as you're developing your decision algorithm, it's an automated process and it has little moments along the way where you can check in from a manual perspective as well. So it's similar to ML ops, but for optimization. So in the ML ops world where you'd be training models, you can see here that we focus on testing, tuning, and reviewing them. And so what does that workflow look like from really high level at NextMove? So what you can see here is what we've created, a very repeatable process that gets you to production confidently. So just quickly from left to right here, you can see from dev, you would likely create a model repository. And when you're ready to make a code change to that model, you'll open a PR. And Nextmove can kick off an experiment like an acceptance test once you've created this PR. And what we're looking for in these tests are not just app functionality, but we're also looking at the quality of the solution as well as critical KPIs. So we can review the results of those tests in the Nextmove console. And if it passes and we're happy with those results, we can go ahead and merge to stable and move that new version into production. If it doesn't pass or there are problems detected that you want to look into further, you can go back to the code to continue working on and tuning that model. Okay, so on to today's topic. We have an integration with OR-Tools that makes it really simple to operationalize your OR-Tools model. So what that means is you can bring your work in progress model that you're still working on or a completely built out OR-Tools model and operationalize that today. So you can use the modeling tools and solvers that you see listed out here, everything that ships with OR-Tools, and using solvers like Glock and Skip, of course, for the routing use cases, scheduling, packing, etc. And so with Nextmove, you can really streamline that dev process. And with that, I am going to dive into our demo setup. So if you've joined us before for any of our presentations, you've probably heard about the Nextmove Farm Share, which is our fictional company that delivers produce from farms to customers' homes. And our current state is that our vehicle fleet is really requiring a lot of frequent maintenance. So we've recently added some more vehicles to our fleet, and we're hoping to reduce the amount of required vehicle maintenance over time and kind of reduce that wear and tear. So what we're going to do is add a constraint for max distance to limit our route distance per vehicle. And so hopefully what that does is activate more vehicles for shorter routes and kind of reduce that wear and tear. So what I will do now is hand it over to you, Lars, to jump into the demo.
Thank you, Rena. Okay, let me share my screen. I hope you can see that okay. Before we dive into the actual farm share demo, I want us to get a little bit of an overview of how you could get started. So I've pulled up a public repository, the community apps repository here. And looking at this list of apps, since this is about Java and OR-Tools, I can see there's two projects in here, the knapsack Java OR-Tools and the routing Java OR-Tools projects that you can use to get started. And we're actually going to use those for starters until we then move it to the farm share example. So if you have the Nextmove CLI installed like me, which you can get for free when you register, you can use that to clone a project from this public repository. So let me do that and cd into it and then open that project, that workspace file. Make that a little bit bigger so you can read it. That's big enough. One less maybe. Okay, so this this app here is actually not our app, or well, it is our app in that we changed a few things, but we got started from taking a sample from the OR-Tools page. So what we've changed here on the left-hand side in comparison to the right-hand side is that on the right-hand side, the input data was baked into the application. But what we're interested in an application that we can send input data to it and get output data back. So instead of printing to the console, we are returning a structure that then gets serialized into JSON. And we're also reading in input in JSON format. So let me show you that real quick. Here's the input file, which mirrors what's in the code on the right-hand side here. So this is our one input file that we'll work with. And well, this is just a normal Java app. I can set a breakpoint. I can start this with hitting F5, and then I can step through it. So you see the breakpoint being hit here, like your normal local dev workflow. Now, running this locally will produce, in this case, because I've run the command with an output parameter, it will produce an output file, which is here, this JSON file. Let me format that real quick so we can see it better. So this is the result. There's like a few vehicles, one of which has a route. That's the exact same solution that you would get. if you ran this example here. And so now we're, of course, interested in running this in our infrastructure. And in order to do this, we have to create an app, as Reno already mentioned. So we're going to do app create -a, give it a name, Java demo -n Java demo. So now we have a container that we can push application to code to, and we're going to do that as next move app push -a Java demo. So what's happening here is we can see it build, right? So it's building first, and then we'll see it upload and push that application code to this container in a second. So how did it know how to do this? There's in this project that we cloned, there's an app YAML file. And this app YAML file has a pre-push hook, if you will, that executes Maven to package this up. So we're using Maven, so we can look at the POM file in a second. And what this does, it produces one asset that's the main jar, and that's what gets packaged up. And then we're using our runtime, the Java runtime, in the cloud. So that's what tells the push command what to do. So the POM file, look at that real brief. You can see that there's two dependencies in here. There's OR-Tools, which deals with the model, and then we have JSON for the input deserialization and output serialization. And then we are using Maven to produce one single jar, which becomes the main jar. And now we have this uploaded here. Okay, so let's make a run on our backend. Next move app run -a Java demo -i the input file. And I'm not interested in writing this to a file, but I want to see this on the console right here. So let's see that coming back. And while this is running, oh, it's already back. So same result came back from our infrastructure. And we can also look at that in the app list. It shows up here in Java demo 53 seconds ago. So let me look at those details, and specifically let me look at runs. There is the one run that I just made. We can click on that, see some details. It succeeded. The input that I sent it. Here's the result with the one vehicle getting the route. All those things. Note that this run ID starts with devint. So devint is basically an internal instance that is used whenever we push code, and so that's a prefix that this run gets. We'll in the farm share example, we'll look at instances and versions, which I haven't created here, in a minute. So remember those when we get to the farm share example. So that's basically the basis for the example you're going to see, because it's the workflow, the CI/CD workflow that we're looking at will use the CLI tool. And so it's important to know how this works. And of course, you want to make this a flow and not always push from console. So we're going to look at that next. So let's look at the farm share repository, which is also public. I forked this here into my personal account from the next move farm share account, so I could add the Java example. And as Randall mentioned, we like this fictional company has an assignment problem and a routing problem. I wanted to solve this with Java code here. So you can also look at that. It's public. And on the left-hand side, we see this opened up. So our business said, well, we want to limit the travel distance. Currently, it's set to max value. The constraint is already there. So let's do that. They said 3,000 meters, or whatever the unit may be, is what we should set. And for the sake of simplicity, for this, I'm not going to create a full PR. I'm going to directly merge the stable. Don't do that in real life. But this will kick off a CI/CD workflow now, this change, and then we can look at that on the right-hand side here. So there is a GitHub action, configure it in this repository, which you can now on the right-hand side see being kicked off. We can look at the details. So what does it do? It installs the CLI, it configures it. We can also on the left-hand side, while this is running on the right-hand side, we can look at the YAML that specifies this workflow. So it pushed the app just like I did, but then there's two more steps, or three more steps, I should say. It creates a version. So what that means is it basically uses the commit SHA from this commit that I just made and tags the pushed binary with that SHA. So we always have a reference to what was the code that belongs to this. And then we have a version with that SHA so we can find it. And then it also updates an instance, which is essentially a named container thing that can also be configured with options. And then it says, okay, this named instance, in this case, the name is development, should point to the version that I just pushed. So it does that. And then also it creates an acceptance test, as Renu already mentioned. And this acceptance test, so all of this is defined here in the YAML file, pushing an app, creating a new version, updating the candidate instance, the development instance. And then we're kicking off an acceptance test, and that's defined by using Python. We didn't have to do that. It can also done via the CLI, but you have the ability to do that in Python. We have an SDK in that as well. Let's look at that code real brief. So we're using Nextmove Cloud SDK, creating a client and an acceptance test. What that says is we have this candidate now with this changed code, which is called development. And then we have a control instance, which is our production instance. We're going to see that in a second. And I want to compare these two. And I have some assumptions about certain metrics and how they should behave, right? And these metrics, in this case, are defined in an acceptance test metrics JSON. In the introduction, we already mentioned that we want more vehicles to be used. So we have a metric that is reflecting activated vehicles or used vehicles. And we think that after this change, it should be greater than what it was before, right? So let's go to the right-hand side here. Go back to this overview and click on the acceptance test link. So now we're in the farm share team. We can also have multiple teams in our cloud backend or in console. And we see the result of this acceptance test. So here's our assumption about activated vehicles. That's the one that I mentioned. And we can see in our test set, we send it some files. There was an acceptance test input set that the production instance didn't have a limitation on max travel distance and no other limitation. So there was one vehicle that could do it all. And now we've limited this. So we activate more vehicles. This is the geometric mean. So yeah, it behaved the way we thought it would. So this already gives us a good feeling of this development instance does do what we think it does. But we can even give us more evidence that this will hold when run in production. And how do we do that? We can create a shadow test. A shadow test is essentially a shadowing instance that will always run whenever there's a run made against production. So let's call that something like max distance limit 3000. We'll say the baseline is production and our candidate is development. That's what I just pushed. And well, we're going to stop this test after 10 runs. So this is now created, and I can kick off in the background. I can kick off some runs with a cron job, and we can see them flow in when we refresh the page. So I'm making runs against production, but in turn, it will always also use the development instance. And then we can see whether for example, the assumption that we activate more vehicles also hold against these instances that flow in, like real production data instances. And that's true. So yeah, we're confident that we can flip the switch and use this development instance in production. How do we do this? We're going to our production instance, edit that, and actually, let's remember the SHA that development was. That was C6, so on. It's the latest commit. So here it is, C6. So we're switching production to the same instance that, or the same version, I should say, that development was using. Okay, so this is a CI/CD flow that gives us some confidence, and there is another test that you can run to give even more evidence that this switch makes sense. But now what if business came back and said, okay, we've seen this change, but what happens if you configure max travel time to something else? Can you give us an analysis, right? Then we also have another test or experiment type, which is called a batch experiment. And since, if you remember, this code here in the options, I've coded a hard value here as the default, but this max travel distance is exposed as an option for the algorithm to be configured from the outside. So I can also go ahead and create an instance and say, this is an instance that configures this value. Give it a name like max dist 2000 maybe. I'm going to use the same code base, but now I'm going to configure a max travel distance and set it to 2000. Right. So this instance now uses the same code as production and development, but it configures this one options to a different value. And now I can compare max dist 2000 against production by running an experiment. So comp max dist 2000 prod or something. I'm going to use the acceptance test input set. Can use another set if I have one. And then I'll choose the instances that I want to run against and run this experiment. And then I can see those runs being kicked off. And of course, I can look at our analysis here, and I can again look at activated vehicles. Should be even less, right? Or even more, I should say, even more because I limited it more. I can also look at the individual run data, download those. I can get a CSV and run more analysis on that. So yeah, that gives us the ability to analyze and compare different option settings without making code changes as well. And with that, I'm going to give it back to you, Reno.
Thanks, Lars. It's wonderful. Quite a lot to cover in just a few minutes. So very much appreciate you walking through that. I will go ahead.
You're welcome.
Back to the presentation just here. Okay, so what just happened? Like I said, Lars did a lot in a short amount of time. So we saw that he deployed the OR-Tools VRP example and made that really a truly operational app with Next Move. So complete with a unique set of API endpoints, able to run it immediately. Then he went ahead and added a constraint to the model and created a PR and used GitHub Actions to kick off an acceptance test. So then we saw him hop over into console and actually take an in-depth look at the experiment results there. And we saw what we expected, right? We saw that more vehicles were being used. So, okay, great. Let's go ahead and now run a shadow test using our production data and see what that results in. He went ahead and ran that directly through the console, looked at those results, and we said, okay, that looks good as well. Passing all of our tests, manually looked at some of the metrics and said, okay, let's ship this new version to production. And the last thing he did there was talk about, what do you do if you want to start to just do some ad hoc analysis and exploration when you hear, you want to tune something, or there are business rules that come in and you just want to kind of explore what things might look like without having to go back into the code. We offer the console as a place to go and tune things. You configure things directly in the console there without having to jump back out into your code editor. So a few takeaways from this talk. We talked about at the beginning how easy it is to integrate NextMove into your existing systems and how you interact with the NextMove app with just simple API calls. You can also start to incorporate decision ops and the practice of decision ops into your workflows for any of your models. Specifically, today we're talking about Java OR-Tools. And you can really practice CI/CD using tools that you might already be using, like GitHub Actions that kick off experiments with NextMove. And NextMove really makes it easy to not only create those experiments, but review the results and share those with your team as well. Lars mentioned that is something that we make easy here at NextMove, is collaborating and making sure that you can share those results and really work together as a team in terms of confidently shipping models to production. So with that, I know we have a few minutes left for Q&A. So let me go ahead and take a look at the chat here. I think we have some questions submitted directly to us. Okay, here's the first one, Lars. Does NextMove provide the CI/CD workflow that you demonstrated? So I think that might be about the, when you kind of kicked off the GitHub action there in that flow.
Right. Yeah. So it's available in that you can look at the public repositories and you have access to the YAML files. So all of that code is public and you can use it. It in turn, as I said, makes use of the NextMove CLI. We don't have yet a GitHub action that you can use from some marketplace or something like that, but you should be good to go if you just take that YAML file.
Okay, another one here. What other input formats do you support? You mentioned JSON during the demo.
Yeah, so we're not limiting the input to anything specific other than that it has to be UTF-8 input. So you can send us CSV or JSON or even Excel, whatever you please. But the app in turn needs to handle that, right? So we're passing that input to your app, and then your app needs to decode or deserialize that input that you're sending.
Great. Okay, and let's put one more question in here. So what's the best way to compare how different tools or solvers perform for my use case? So is there a way to do that with NextMove?
Yeah, absolutely. So I, in my personal account, I don't know if you saw that, but I have different solvers there as well for the routing use case. And as long as you can make the input conform to the same structure, like modify the input reading part of your app, it's really easy because then you can just push all these different codes to your app, to the one app that you use for experimentation. And then they should also, of course, produce a similar output. At least the metrics that you care about should be in the same structure. And then you can use the same experimentation framework that I use, like the batch experiment, for example, to compare those results. But as I said, the input needs to be in the same format, so you can use one input set that all of the apps that you want to test can handle it.
Perfect. Thank you. I think we are just at time here, so I will go ahead and say some closing words. So please, for your next step, go ahead and create a free NextMove account. It's free to get started. You can go ahead and dive into all of the things that Lars just walked through with the free trial. Talk to our team. We love talking about all things optimization and OR, as you can tell. So please feel free to reach out to us. And stay tuned for more videos just like this one. We have another tech talk coming up on April 10th. where we'll be talking about getting started with decision ops using Gurobi. So please join us for that one. In the meantime, check out our documentation and blog, and we hope to see you on the next Tech Talk. Thank you so much for joining us.